Now let's consider a couple of things that are related to your location on the surface of the Earth. Here are some questions. What are two systems used to specify a location? What is the difference in units between the two systems? And how could you find the position of a rain gauge that you placed near your home, okay, or where you live? So keep those two questions, or those three questions in mind while I go through different aspects of coordinate systems. Okay, first, let's think of latitude and longitude. This is a system that really essentially consists of concentric circles that are evenly spaced between the poles. These are have their origins at the equator, which is considered to be 0 degrees, and the poles are 90 degrees north and south. So the units for this are degrees. Longitude also consists of circles, though they're no longer concentric, they're intersecting at the poles. They're called meridians, and they're equally spaced, and they intersect at the poles, and the reference point is the prime meridian, which is considered to be 0 degrees longitude, that passes through Greenwich, England. We have negative values west of the prime meridian and positive values east of the prime meridian. So when we talk about measurements of longitude in Nevada, we're always talking about negative values. Another system is the Universal Trans Mercator system, or UTM. This is a grid-based system that consists of 60 zones. It was developed by the U.S. Army Corps of Engineers in the 1940s. It's based on the Mercator projection, which is a projection of the Earth's surface to make it flat so that we can delineate things like the Universal Trans Mercator system, or latitude and longitude. And the 60 zones span 80 degrees south to 80 degrees north latitude. Each zone spans about 6 degrees of longitude and is centered over a meridian of longitude. Here's a depiction of the Universal Trans Mercator system. And when I talk about the projection of the map, there are many different projections of maps, but essentially what we're doing when we take a projection of a map is taking a spherical object, that's our Earth's surface, and making it into a flat surface that we can impose a grid on. You can see here that we have our grid that's composed of letters running from north to south, and numbers running from east to west. Let's look more carefully at the portion that covers the western United States. You can see that we are in Zone 11, which spans the longitudes of 120 to negative 120 to negative 114 degrees. So let's see where we are. Well, this is a Google Earth. Here's the University of Nevada campus, and this is a Google Earth image of the University of Nevada campus. The X is approximately where the Davidson Math Science Building is, where we are right now. I've put an X there. And let's take a quick look and see how that's represented in the two different coordinate systems. Using Google Earth is a good way to do this. ArcGIS is another good way to do this, and I'll demonstrate that in class. We are in UTM zone 11S. We are our easting, which is the way the UTM zone or UTM coordinates work, which is the projected distance from the central meridian of 120 degrees, is 258,311.08 meters. Our northing, which is the distance above the equator, is 4,380,375.3 meters north of the equator. Using the latitude and longitude system, our X lies at 39.539096 degrees north and negative 119.812347 degrees west. That's in decimal degrees. We can also express that in degrees, minutes, and seconds. When we use ArcGIS online, we prefer to express our degrees in decimal degrees, whether we're talking about the location of a stream gauge or a rain gauge. In In degrees, minutes, and seconds though, the same position that we indicated above with decimal degrees is 39 degrees, 32 minutes, 20.59 seconds north, and negative 119, 44 minutes, 44.24 seconds west. Using Google Earth, we can also see that we're at 4,546 feet of elevation. So what are two systems? And there are several that are used to specify location. Latitude and longitude, which can be expressed in decimal degrees or in degrees, minutes, seconds, and the UTM coordinates, which are expressed as easting and northing, and they're specific to one of the grid points or one of the grids that has been superimposed on the Earth's surface. The difference in units: the latitude-longitude system uses degrees, and the UTM system is based on the metric system, which is in meters. And how could you find the position of a rain gauge that you place near your home? You could do that by using Google Earth or ArcGIS Online and the measure function, locating the spot where the rain gauge is, either with a base of photographic imagery, as we did in this example, or with a topographic map, digital topographic map. Use the measure function and find the position in either UTM or degrees, minutes, seconds, or decimal degrees.